This video introduces pointers by demonstration. So let's start with a very familiar an integer number, which I'll assign the value 256, and we'll output this number. The value is equal to num. We'll compile this program and execute, and num has the value of 256. Alright, we can also take a look at the location in memory of num, which is by using an ampersand in front of the variable name, as so. So let's take a look at what that looks like. So num has a value of 256 and is located in memory at this address. Okay, cool. Can we see the value stored in the location in memory? Let's take a look. And the way we would do this is by putting the asterisk in front of the variable name. It's known as dereferencing. And so what this will do is it will go to the location, it'll go to the location in memory of the value. So it'll go to the location in memory 256 and get whatever data is stored there and output that. Let's see if that's possible. And we get an error, invalid type of argument unary, asterisk. Okay, so it's not actually possible to look at the value stored in this value, the value of the number. And that's because we're not actually using a pointer, we're using an integer. So this line of code doesn't actually make any sense. So what we'll do is we'll make a pointer, and the way we distinguish that this is a pointer is by putting this asterisk along with the data type. So this is to tell us that it's a pointer to an integer, or an integer pointer. And I'm initializing the pointer to 0 because 0 is not a valid memory location. Okay, so what we'll do now is we'll output the data stored inside of pointer. So let's look at the value of pointer. Compile and execute. So number has 256 as the value with this memory location, and pointer has the value of 0, which is what we've assigned it to. So we can look at also the location in memory of our pointer with the exact same ampersand prepended to the variable name. Let's compile and take a look at this. So we have the location in memory of our pointer, which is actually very close to location in memory of the other variable, the integer. The only difference here is this has a C at the end, and this has an 8, which is a 4-byte or 32-bit difference, which on my computer is actually the size of an int. What about now, can we take a look at the value stored in the location in memory of pointer's value? Let's look at the value of pointer. And next, let's go to the location in memory of this value in the pointer and get the data stored at that position in memory. We're going to read the data in memory as an integer, which is why we have the int in integer pointer. So we're going to get the number of bytes that an integer would have at the location in memory stored in pointer. So let's see what this looks like. We run and we get a seg fault when we go to look at what pointer is pointing to. So the memory location that we're pointing to is actually 0, because our integer pointer is initialized to 0 and we haven't changed that value. And so we go to the location in memory at address 0, which is not a valid memory address, and we request to look at the integer stored at memory location 0. Well, it's not a valid memory address, and so the program actually crashes with a seg fault. So let's assign our pointer the address of number. So we're going to take the number address, which is just a location in memory, that memory address, and we're going to store the value of pointer. Now, when we dereference our pointer, we will go to the location in memory that's storing the value of num. Let's compile and take a look. So the value of num is 256. The location in memory is shown here. The pointer value is the same as the location in memory of the variable num. So we're pointing to num, and the pointer has its own location in memory, which is again very close to the num's location in memory. And finally, the value stored in the location in memory of the pointer's value is 256. Well, that's right, because we're just pointing to the variable num, which has the value 256. That's a quick rundown of pointers. Thank you.